So I will be presenting on AI augmented printed flexible hybrid electronics. This is work we are doing at ETS in Montreal. So for those of you who are not familiar with flexible hybrid electronics, the overall idea is to combine printed circuit components with standard surface mount package, commercial package components, and to combine them into those hybrid electronic circuits and devices. And of course, the idea is to get the best of both worlds. So here are a few examples of work that our team has been doing in recent years. We print on different kind of materials and we combine and assemble package components to achieve functional circuits and systems. So our lab does a lot of work on the material development. So some of our students developed new ink formulations that have now turned into commercial products used, for example, to print solar cells or print for printable ceramics. These materials can be integrated into flexible hybrid circuits for sensing and for energy harvesting applications. This is a collaboration that we're pursuing with the C2MI in Bromont. So C2MI is a private research center we're affiliated mostly with Teledyne, DALSA, and IBM and other industry partners as well. And the idea is to accelerate the transition from the lab to commercial products. So we work with them on the development of new flexible hybrid electronic solutions. And in recent years, one of the concerns that we've tried to tackle is to really work on the scaling up of those technologies. So we went from doing research. Well, I mean, we're a university, so we went from doing research using conventional research equipment and more trying to do research earlier on manufacturing equipment. And the idea is that once we develop something that works, we can transition more quickly into commercial products. So the process for flexible hybrid electronics starts with screen printing. So this is the screener that we're using at C2MI. We also have those screeners at ETS. So we will print the conductive material. Then we also do a lot of work on digital inkjet printing. We have quite a few interesting tools. So here's a Saja printer that is more for, I will say, research or small size production because it gives us a tremendous control over the whole printing process. And then in recent years, we really started to pay a lot of attention to printing of copper inks. We really believe that for mass stream production of flexible hybrid electronics, we have to stay as close as possible to what is normally used in regular PCBs, which are mostly copper-based. So flexible hybrid electronics, most commercial solution currently use silver, and we're really investing a lot of efforts together with C2MI to move towards copper prints to avoid problems like electromigration and soldering compatibility issues. We also work extensively on photonic post-processing. So once the material is printed, we need to sinter because those are particle-based inks. So we need to sinter them. And of course, when you work on a low temperature substrate, that can bring a lot of challenges. Here's some example of nickel ink that was sintered on cardboard paper, SBS paper, using photonic curing. So we can anneal the nickel on top and bring it to very high temperature while preserving the structural integrity of the substrate underneath. And using photonic curing, we can achieve now conductivities that are on par with what you would achieve with a thermal annealing process, which the substrate cannot sustain. Then we assemble the components.